And I think, well, there's more than one answer, but I'll give you what I consider one of the important parts of the answer. When System 1, when asked a single question, and it can be asked from the outside, or it can be a question that you generate for yourself, that is, you develop the goal of finding an answer to a question. If the question is too difficult, System 1 answers a simpler one. That is, what happens is typically we don't compute when we face a question. We don't compute a single answer. Many computations go on. I call that the mental shotgun. It's not a single bullet. It's just many pellets are sent. Many computations go on. I'll give you an example of that. Suppose you are told to respond as quickly as possible if a pair of words rhyme. So you raise one hand, say if the words rhyme, and the other hand if the words don't rhyme. And psychologists do that kind of thing, and they measure the speed at which people respond. So I say vote note. That's very easy. Those two words rhyme. I say vote goat. Those two words rhyme. People are much slower saying that they rhyme. Now why? It is because they have carried out a computation that nobody asked them to carry out, that they did not intend to carry out. They spell the words. They spell the words, and there is a mismatch in the spelling between vote and goat. That creates a no response, a tendency to answer no. That's a mismatch, which interferes with the response that you really intend to produce, which is a response to whether the words rhyme or not. That is highly typical. We generate answers to multiple questions immediately in our head when we're asked a single one, in many cases. And in some cases, the answer to the correct question doesn't come up at all. You're never aware of it, but the answer to another question comes up. So let me give you an example of this. Here, if people are asked the question, how tall are the three figures? How large are the three figures on the screen? This experiment has been run many times. People think the figure on the right is larger than the figure on the left on the screen. It is not. If you took a ruler, the three figures are absolutely identical. What happens is we answer a question that we're not asked to answer. We compute the three-dimensional size of those figures, not on the screen, but if this were a three-dimensional image, who would be taller? It's the guy on the right. And that's what happens. Now, people are not confused. You know that you've been asked to think about the screen, but there is another answer, which is quite powerful, and it distorts what you will say to that direct question. Here is another example of the same kind of mechanism of answering a question because the answer to a simpler one is available. So this was done with students, and in a survey, students were asked two questions in immediate succession. How happy are you? And how many dates did you have last month? When people are asked those two questions in that sequence, they're essentially uncorrelated. Turns out dating is not what determines students' happiness. Now you invert the order of the questions. So you ask them, how many dates did you have last month? How happy are you? Now the correlation jumps to 0.66. It's very, very high. In effect, what they do, the question, how happy are you, is a difficult question. But they have an answer. There is an answer available in System 1. You have the question, how many dates did you have last month, created an emotional response, which presumably is a happy one if you had many, and is not a happy one if you didn't have any. And so that emotional tone is available. When the question, how happy are you, comes up, that's the answer that gets generated. So we call that the substitution principle. And the substitution principle means that you answer a question that is simpler than the one you're asked. This happens all over the place. And in effect, it serves us extremely well, because much of the time, there'll be a relationship. You'll answer not exactly the question you were asked, but you'll do something. You won't be stumped. System 1 is rarely stumped. It produces something most of the time. 17 times 24, no, but in many other cases, yes. Let me give you an example. I'm trying to remember the Canadian grading system, but which I should know because I taught at UBC for 8 years. But let me tell you about a student. Her name is Julie, and I'll give you one fact about Julie. She read fluently when she was age 4. And I ask you, what is her grade point average? And the odd thing is, like in the other cases that I mentioned, a number came to your mind. Your mind produced a number. It's the wrong number, by the way. But let me explain how the number came to your mind. The fact Julie read fluently when she was age 4 creates an impression. You have an impression of how bright she is. Actually, how bright she is something else. You have an impression of how precocious she was in acquiring reading. She was quite precocious. Not exceptionally precocious. Some people read at age 2 or less, but, quite precocious. So you have some vague idea. It's not very precise, but you have an idea of, in percentile terms, how many people read earlier than age 4? Not many. What did you do with the question, what is her grade point average? You actually matched the percentile. You produced an answer, a grade point average, which is about as extreme as your impression of a grade point average. That's the way intuition works. It is absurd. Actually, you know very, very little about Julie. One fact. But you predict, in effect, as if the correlation between reading age and grade point average was perfect. It is not perfect. You know virtually nothing about Julie. You should stay very close to the average in predicting her grade point average. In statistical terms, you should be very regressive. Our intuitions are completely non-regressive. This is a major characteristic of System 1. It is extremely poor at dealing with statistics. And it is prone to tell stories, and the stories are told, the stories are generated even with very little information. So you get one fact about Julie, and you have an idea. I'll give you another example. Steve is a meek and tidy soul with a passion for detail. Now, Steve has been, selected at random from the population of Canada. What is the probability that Steve is a librarian rather than a farmer? Now, one fact jumps immediately to mind, which is Steve looks like a librarian. The stereotype, the match of the stereotypes comes immediately to mind. There is a bit of statistics that's relevant here. I know the statistics for the United States. For Canada, it would be more extreme. In the United States, there are 20 times as many male farmers as male librarians. So in effect, any calculation that is sensible, Steve is significantly more likely to be a farmer than a librarian, even though he is a meek and tidy soul. There are many meek and tidy souls among farmers, not only among librarians. That's the way a correct system would compute it. Our intuitive system does not. So it tells a story even when there is little information. Furthermore, the confidence we have in that story, in those stories, is determined by how coherent they are, by how much sense you can make of the information and the conclusion. If it's a coherent story, we believe it. If we have difficulty generating a story, we doubt. System 1 produces the most coherent story possible. The result is massive overconfidence. Why? Because we are really good storytellers. We tell ourselves stories with very little information. And if the stories are good, we believe them. System 2 believes them. And the result is that System 2 has much greater belief in its opinions, its belief, the correctness of its decisions than it really should have. And that is because of the way that System 1 works.